Hi again. Well, we're continuing our hypothesis testing of two parameters. And let's look at another example in case it's not quite clear yet. I know we have just done one so far. Let's look at another one. We're going to look at treatments for cocaine addiction, and we've used this data set before, so I hope that will be helpful and also interesting to you at the same time. So when we were looking at contingency tables and probabilities and conditional probabilities and independence testing, we used this data set, okay? So recall we have this cocaine treatment experiment, and we had a control group and then two different treatments, okay? We did an independence test and we noticed a difference in the success rates between the different treatment groups, okay? So we can also, that's one way to kind of see were the results significant. And another way is to use a hypothesis test. Okay, so in this test, we're going to look at two proportions at a time. So think of this as like a yes-no thing, right? This is a categorical variable. Was there a relapse or not a relapse? Did they return to using cocaine or not during the study? Okay, so these are proportions because it's a categorical variable, and we use these tables, contingency tables, for categorical variables. There's three groups, that's a category, and then the output, outcome, or response, that is a category as well. Okay, so what are we going to test specifically? Because there's a few different things we could test. This says test the hypothesis that taking the drug lithium reduces the proportion of participants that have a relapse compared with placebo. Okay, so we're going to just compare two things at a time for right now. That's enough. We're going to compare the lithium and placebo groups. We're not going to use dicipramine at all right now, but that's another test, and you can do that one. Okay, what's the parameter of interest and what's the direction of the test? Use this to write the hypotheses. Okay, parameter of interest. So we know we're talking about proportions, and we've got two things. We're comparing lithium with placebo. Okay, so that tells me it's the difference of two proportions. Okay, so I'm going to write out difference of two proportions. Also, I want to write the direction, which I don't think I did last time. Reduces the proportion. So here we're comparing relapse, which is the thing we don't want, right? So smaller is better. And so this is going to be a left tail test because of the reduces. I'll write it under here. Reduces is going to the left. Smaller is better. Okay, so let's write out our hypotheses. So our null, remember our null is always that there's no difference between the two groups, okay? And because we're using proportions, I'm going to use a P, and then I'm going to use a subscript for each group, okay? So I'm going to use P sub L, and that's equal to P sub P, which is kind of funny. The proportion who had a relapse in the lithium group is equal or no different from the proportion who had a relapse in the placebo group, okay? And another thing I want to make a note of here that's not really written here yet is that we are specifically comparing relapse. So we're looking, I'm going to put an arrow on the relapse column because that's reducing the proportion of participants who have a relapse. Before, I think we compared the no relapse numbers because it's just more intuitive that higher is better. But we're specifically testing, in this case, the relapse. So, okay, so I'm going to say difference of two proportions, and I'm just going to write relapse right there. So we know which one we're looking at, the relapse or the no relapse. Okay, so just like with our means, we could also write this as a subtraction. So, or PL minus PP is equal to 0. So if there's no difference, they're equal to each other, or the difference is equal to 0. Okay, let's write our alternate hypothesis. Okay, so it's a left tail test, and lithium should be better than placebo, right? It's a that's our claim. Lithium is better. It reduces the proportion. So that means the proportion for lithium should be less than the proportion for placebo. Proportion of relapse for lithium is less than the proportion of relapse for placebo. Or if I write that in a subtraction, PL minus PP is less than 0. Okay, if I take the proportion who relapsed on lithium, subtract the proportion who relapsed on placebo, that should be less than 0. Right? Yes, yeah. These are kind of little mind benders there. So if the proportion is less and you subtract something that's more, it should be negative, right? Okay, we'll use the numbers and then I think that'll help as well, but just wanted to double check that. Okay, so we can look at this with our numbers up here. We'll see that they're in the applet as well. Okay, so for this next part, using an appropriate randomization applet, select the dataset or enter the observed statistics and simulate the randomization distribution for the sample size used in the study. Okay, let's go to the app here. Okay, so again, just going to the StatKey main page because these will be mixed up in general, so you won't know which one you need to go to. Or you will decide which one you need to go to. We're going to go to the test for difference in proportions. I'm going to click on that one. And then some of these are in here, but we could also enter them ourselves. So let me show you both ways for that. So first let's go to clicking on the little tab on the upper left for the data set. So I'm going to look for cocaine addiction. There's 2 of them. You'll see one for lithium and one for disopramine. So we're doing the lithium one. And you'll see our same hypotheses, but they're using the 1 and 2 again because they don't change the subscript according to the data set. So we got to figure out which one is which again. And over here you see the original sample. This matches our data set in the notes. So lithium under relapse was 18 out of 24. Now they're not giving us the 6. They're just saying 18 out of 24. And placebo is 20 out of 24. Okay, so let me go back to the notes real quick and show you where that is in our table. So relapse for lithium is 18 out of 24, and that's going to be our p hat, right? That's our observed statistic. So that's going to be p hat L is 18 out of 24, and I bet the app has already divided that for us. And then the placebo, so p hat placebo is 20 out of 24. Okay, let's just go ahead and divide it, and then we can check the computer. So 18 out of 24 is 75%. Okay, it's a really challenging addiction. So 75% did relapse on the lithium, but even more, 20 out of 24 is 0.83 repeating, so 8333. Okay, so it is less, but remember our question is that due to chance or is that due to the treatment itself? Okay, so let's flip over to the app and see if we have those same numbers. We should see the 0.75 and the 0.8333. Okay, bingo, right there. 0.75 and 8333. Okay. And then, okay, this is nice. So even though they're using 1 and 2 up here, P1 equals P2 and P hat 1 minus P hat 2, they are writing the direction of the subtraction, lithium minus placebo. So that's a double check. We always want to double check that we're subtracting in the same way, right, as the app. Otherwise, our results will be reversed. So they are writing L minus P, or lithium minus placebo. So that does really help. Okay, now let's say we were using a table that wasn't a data set in this app. If I clicked on Edit Data, you can see I could enter the things I just divided, which are our observed statistics. I could enter 18 out of 24. That's group 1 count over total. And then I could enter 20 out of 24. Okay, so you can do this with any two proportions, and we don't need the whole data set. It's different than means, where you need all of the people. Well, this is the way to put all the people in, but because it's a proportion, it's just easier to enter than it is for means. Okay, so I'm going to X that, and okay, luckily it kept everything the same there. Okay, so do you remember what the next step is after this? We've got our original sample in here. Now we need to generate our randomization distribution, right? Or as they're saying, randomization dot plot. And we're setting it up based on the idea that the null is true, that there's no difference between the two groups, okay? So again, this time we have 48 people, right? 20, 30. Yeah, it's not, you can't add the 18 and 20 because the other 6 and 4 are not in this table. So I've got to add the 24 and 24. So there's 48 people here. So under the null, same with the beer and water. Under the null, we're saying there's no difference. So we could shuffle these cards up. Let's say we put whether for each of the 48 people, whether they had a relapse or not, we shuffle them up and we re-deal them out into two groups of 24 and count. So that's what this computer is doing each time. So if I generate one random sample, again, we're using the reallocation method. It's not resampling, it's a reallocation. Oops, I just lost my sample by clicking on that. Let me do another one. Okay, so it reshuffled the cards, and this time 20 people who had a relapse were in the lithium group and 18 were in the placebo group. So that's a difference of a positive 2. Lithium minus placebo, so 2 higher in the lithium. And so then we see dividing that by the 2 by the 48. I'm pretty sure that's what it's dividing by. Oh, okay, so it's subtracting it's subtracting the two proportions. That's where it's coming from. So it's taking 0.8333 minus 0.750, and so it's a difference of 2, and the difference in the proportions is right there. Okay, so it's a positive difference because the lithium was higher, versus in our original sample, it was a negative difference because the placebo was higher. And remember, smaller is better in this case. We don't want to have a relapse, if at all possible. So let's generate another sample. Let's do a few of these. That one came out the exact same way, just by chance, right? I'm sure we're going to get something that's not 18 and 20 or 20 and 18, but so far, there we go. So now we got a 17 and a 21. Again, just by reshuffling all the 48 people. Let's say the random assignment was just set up in a different way, and assuming there's no effect. Now we got exactly 0, 19, and 19. And so you see that is right on the null of 0. 0 difference. Okay, is this making sense to you? Let's do a few more. So another 21, so 21 and 17, another 19 and 19. Okay, so now let's go ahead and do around 2,000. I'll just click generate 1,000 samples 2 more times. Okay, so this does look very symmetric, doesn't it? Notice with proportions, you don't have all the gaps filled in because it's discrete, so you can't get certain proportions you can't get. So it's a very beautiful picture. It does look roughly symmetric. And now we want to put in our p-value, okay? So our test statistic, which I had written on the notes, I just didn't subtract them yet. but we did the 18 out of 24 and the 20 out of 24, and we got the 0.75 and 0.833. When we subtract the two, we get a negative 0.083. Okay, so I'll write that back on the notes. Let me just do that right now real quick. Whoops. Let me keep this up here. So if I go ahead and do my p hat L minus p hat P, that's 0.75 minus 0.833. This applet is using 3 digits. 0.75 minus 0.833 is negative 0.083. Okay. So it's a pretty small difference, right? So we want to know where, if there really is no difference, where would this fall on the graph? Okay, so we're going to select left tail because this is a left tail test because smaller is better. And then it always comes up with 0.025 for this probability. So we don't want that. We want to actually put in our sample statistic, and if it's negative, be sure to put it in the negative. It's negative 0.083. Okay, so we can see there wasn't much difference, right? It wasn't, yeah, so there's a lot of red X's indicating that in this simulation, many times we got a difference that was that small, a difference of negative 0.083. In fact, it was about 35% of the time, 35.4% of the time. So our p-value is 0.354. Okay, and also keep in mind the sample size has an effect on this as well. If it was a larger sample size, you can detect, the same difference could be more significant if it's a larger sample size. We'll explore more about that later on. Okay, but for right now, let's go ahead and write our p-value. So there is not a significant difference between these two groups. There we saw there was only a difference of 2 people, but we weren't sure. Is that significant or not? So we did the test. We found out it's not a significant difference. So let's go ahead and go back to the notes, and I'll write down the p-value. Actually, I'm going to write it down before I leave this. .354. Okay, so now let me go back to the notes. Okay, so we did this. So we used an appropriate randomization applet, selected the data set or entered the observed statistics, simulated the random distribution for sample size in the study. Okay, so we did that. We got a p-value of 0.354, and now there's a screenshot of what we had here. Let's see if it came out any different the other time. Okay, so the other time was 0.380, so pretty close. And both not significant at all, right? Both no, very much in favor of the null. Okay, so let's kind of recap what we did on here. So remember we have p hat 1 minus p hat 2. This is a left tail test because smaller is what we want. Smaller is what we're looking for. And here's our sample statistic. This is p hat L minus p hat P. And the output from the applet, negative 0.083. And so we put that in our, and when we click left tail, we put that in on the horizontal axis. This is our observed statistic. We put that in and we get our p-value. Okay, I need my next page so I can write the conclusion. Isn't this fun? I hope you really enjoy the two-tail test. There's more to it in theory, which we won't have enough time to do in this class, so that's why it's so exciting that we can do it with the simulation. It's cool when you get to the theory also, but it's really really short and sweet with the simulation once you get practiced at it. Okay, so our next step is to compare the p-value with the significance level alpha and determine whether the result is statistically significant. Okay, I'm looking back up and I don't see an alpha given. Remember, if it's not given, we use 0.5, so I'm going to use alpha equals 0.05. I wrote that out last time, so I'm not going to write it again. When it's not given, we use that as the default. So I'm going to compare the p-value of 0.3. I could use either one, 354 or 380. Last time I used the one that was printed on, so I'll use that one again. The p-value of 0.380 is greater than, right? 38% is greater than 5%, much, much greater. So this result is not significant. Not significant. And then let's write out our conclusion. Okay, similar to what we did last time, but this is the opposite conclusion because it's not significant. With a p-value of 0.380, this time I'm going to write whether we reject or fail to reject the null first. Okay, we fail to reject the null, and the result, or because the result is not statistically significant. Okay, and now's where I need to put it in context, right? What does that mean in terms of the treatments for cocaine addiction? And this is where I'm going to go back to the claim. Test the hypothesis that, okay, taking the drug lithium reduces the proportion of participants that have a relapse compared with placebo. Okay, so this was not, it did not significantly reduce, right? So I'm just going to keep that, so I can keep looking at that on the side here. So taking the drug, so we do not have evidence that taking the drug lithium significantly, or just because I already said it's not statistically significant, do not have evidence that taking the drug lithium reduces the relapse rate compared, let's see, I need to say for cocaine addiction. Get my full context in there. Compared with a placebo. Okay, now have we proved that lithium does not work in this case? So that's why we want to be able to make sure our studies are repeatable and reproducible. Maybe it was something in the way the study was done. So it's like we haven't really proved that it doesn't work. We just don't have evidence that it does work in this case, right? Or maybe it works for something else. So we're just saying what we have evidence or don't have evidence for. We do not have evidence that taking the drug lithium reduces the relapse rate for cocaine addiction compared with a placebo. Okay? Okay, great. Well, now you get to practice some of these yourselves, and I'll see you in the next video.